let's go to compiling and linking with libraries. And in this case, we have here already loaded FOSS, which is maybe what we would do if we wanted to compile something. Yeah. So let's look at what compilers are at ASP.C2N and how to use them, and some popular flags, and also how you link with libraries. There are compilers available for Fortran 77, Fortran 90, Fortran 95, C and C++, as well as Clang and a few others. Compilers can give you both general purpose code and architecture-specific optimized code. So you can do loop level optimizations, interprocedural analysis, and cache optimizations. So first, you would need to load a compiler suite and possibly more libraries depending on what you need. And as we mentioned in the module section, you use MLAV to get all the available compiler toolchains. And you load it just like you load any other module. You will always have them available directly. There is no prerequisites for these. And yeah, that's code along. Open a terminal to work in if you're using Thinlink instead of regular SSH. So I will meanwhile purge so I don't have anything loaded. Then I will do clear so I have access to the top of the page here. And this compiler toolchain, FOSS 2023B, it contains GCC, BLAS, LAPACK, SCALAPACK, and FFTB, as I mentioned. I will load it again and can do the same. So now it's loaded. And we have the things loaded that you see here also. And then we will look at compiling. OpenMP, all the compilers has this included, so it's enough to load the module for a specific compiler toolchain and then add an appropriate flag. Do note when you're compiling something, if you don't name the executable using the flag -o and whatever name you want to use for the executable, it will be named a.out as default. That also means that next time you compile something, if you don't name that also, then it overrides the previous a.out file, and you may not want that. So I, in general, always name things. So to compile, then compiler names, if you're using GCC for Fortran, all of them are called gfortran. With MPI, it's MPI F77 or F90. You cannot use it for Fortran 95. If it's C, then it's GCC and MPI CC. If it's C++, it's G++ or MPI capital CC. So in order to use the MPI compilers, of course, you need to load a compiler toolchain which has an MPI library. And in this case, it has OpenMPI version 4.16. So let's go ahead and compile a C program. I am going to go into my directory here. And let's look at the stuff I cloned. So I go into intro course. Here is the directory exercises. It has the same content as this exercises I got from untarring the tarball I copied. So either one will work. So make sure you are in the exercises directory. Under exercises, there is a subdirectory that's called simple. And that's everything that I'm going to work with when I'm talking about it here, and also batch programs will be there for when we run those. all the other many directories are some that Pedro will use some of. So I'm going into simple, and as you can see here, there's a lot of different files. The one that ends in .sh are going to be used for the batch examples, so let's ignore those for now. Here I'm going to compile the C program hello.c. Let's find it. It's here. And I'm going to name the executable hello. So again, I will say GCC. And I want to compile hello.c. I want to name the executable, and I want to name it hello. And I got it here, hello. And I'm able to run it if I just say ./hello. It says hello world, and that is what I expected from this small program that I wrote earlier. So if it was instead an MPI program, and here I'm going to look at MPI C programs, then I have one, and it's called MPI hello C, and I'm going to compile it with MPI CC, MPI hello .c, which was the name of it. Oops, sub, and then -o, naming the executable, MPI underscore hello. And you are not supposed to run that on the login node, but it should be possible to run it anyway. And something has happened, which means that I cannot type. Okay, I don't know what happened. I'm going to log in again to Kebnekaise. I don't know why my access froze. Okay, Kebnekaise is having a bad time. That's why. Okay, then I will just continue talking and we can do some exercises later. Hopefully everything will be back up and running again soon. In any case, I can run this, as I said, with the MPI run and then MPI underscore hello. And doing so would have just returned hello from this core that I was running it on. If you later have loaded a different compiler than the one your program was compiled with, then you should recompile your program before running it. Let's see. That's up. Okay. Because there might be some differences with the libraries and stuff, so you should recompile if you're using a different compiler. And then there was an exercise, and we're going to have to wait until Kebnekaise is up again. So load FOSS 2023b and compile it like I showed you. And then you could try and unload the module and load another module, namely the Intel one, and see if you can run it with MPI run MPI underscore hello. And my expectation would be that you couldn't. So a list of commonly used flags. The one we have just used is -o and the file we want to call our executable. We could also just compile or ensemble source files but not link with the libraries and stuff. Then we use that. And an important one is -f openmp, which you would use if you're compiling an openmp program. Then there are some for debugging and things. So I will continue. I cannot connect to Kebnekaise, unfortunately. It seems to be down. Uh, in the exercises directory, there is a subdirectory called simple, as I showed you. Under that, you find my exercises and my example files. There's one called omp_hello.c. In order to compile it, you do gcc -f openmp omp_hello.c, the name of the file, -o to name the executable, and I'm naming it omp_hello. -f openmp is what you add to compile an OpenMP program under GCC. When you run it, you can change the number of threads with export omp_num_threads equal the number of threads you want. And when you can again log into Kebnekaise, you can test run the binary you got. You can set the number of threads to 1, 2, 4, 8, and try run it and see that you get a different number of answers depending on how many threads you have. And you can try with a different toolchain or version if you want to. And then just remember to unload or purge, load the new toolchain, compile the program again and run. It shouldn't make a difference. Compiling with Intel. Here the compiler name is named iFort for Fortran's compiler, and ICC and ICPS for the C and C++ compilers. For MPI, it's MPI iFort for Fortran and MPI ICC for both of the C and C++. Yes, remember that you need a toolchain that has an MPI library. And FOSS has, so any of the FOSSes you could load, and then you could then compile hello C and yeah, call it hello_intel to not override it. I didn't do that here, but that's a good idea if you want to keep both of them. Then there are some commonly used flags, many of them the same for Intel and GCC, but not all of them. So it's important to check. Mainly if you're compiling for OpenMP, then it's -q OpenMP instead of -f OpenMP. Just check if it has returned. It has not. Okay. So when you link, you will usually you are using you can use just a compiler toolchain, but it will be a fair bit of manual work figuring out how to add -L or -L for including files and libraries and similar. What will make it easier for you is that there is a specific build module available that's called build_env. And after loading any toolchain, you can load build_env. And if one is missing for a specific toolchain, ask us and we will install it. That module defines a large number of environment variables with relevant settings for the used toolchain. It sets many of these like CC, C flags, F flags, MPCC, and things like this, which you would be using, for instance, in your make files. And when you have loaded a toolchain, load build_env and then do ml show build_env. It will give you a long list of environment variables that you can use. And if you need to preface it with a $sign when you are linking, and it makes it much easier to use. For instance, if you were linking with laypack, so you have your compilation, and then it would be -L flexiblas -LG Fortran, or you could just use the environment variable $liblaypack, which is identical to this. So you can do that as soon as you have loaded build_env. And the good thing about that is that even if something is, if you get a different version, if it's renamed things or stuff, then this will still be the same. So it makes it easier. And here is just an example of how you would do this. And yeah, you can try and do this when access to Kebnekaise has been restored. And on this documentation page, I have gathered all the more used libraries, and I forgot to update the path when I updated them. But they are here under libraries. There is a bunch of them, and it should be explained everywhere how you load it and use it. So some key points: in order to compile a program, you must load a compiler toolchain. Kebnekaise has GCC and Intel compilers. GCC compilers are G-Fortran, GCC, G++. Intel compilers are iFort, ICC, and ICPC. Compiling MPI programs can be done when you have loaded compiler toolchains containing MPI libraries. Easiest way to figure out how to link with a library is to use ml show build-in after loading a compiler toolchain.